Particles P and Q of masses 10 kilograms and 8 kilograms are attached to the ends of a light inextensible string. The string passes over a light smooth fixed pulley with P lying on a rough horizontal surface and Q hanging freely. Notice it's a rough surface this time, so there's going to be friction. The string is initially taut, and once released, P experiences a resistance of 0.1 G. The system is released from rest. Find the acceleration of the system, the tension in the string. Let's look at Q first, because that's no different to the last example. We've got hg acting downwards and T upwards. The tension is still the same throughout the string. Light smooth pulley, remember. But this time we have 0.1 G of resistance from the rough surface. The 10G and the reaction force, of course, are not in the direction of motion. When released, it must accelerate this way. The acceleration is the same because of the inextensible string. The resultant force is 8G minus T, and that's going to be equal to 8A. And if we look at the resultant force is T, take away 0.1 G, and that's going to be equal to 10A. So let's call that 2. Now this time if we add 1, the T's do disappear, but we end up with 7.9 G. 8G take away 0.1 equals 18A. So the acceleration is going to be 7.9 G over 18. Not nice to leave a fraction with a decimal there. So let's call that 79G over 180. Now, we also want the tension. So going from 2, T is going to be 10A plus 0.1 G. Well, 10A is going to be 79G over 18, and then we've got plus 1 over 10G. So what we really want there is a common denominator. 180, so make that 1790G, and then this one would be 18G. So we would have 8, so 790, add 18 is 808. And we could probably cancel down a bit here, so 808 divided by 180, 202 over 45.